Good evening, everyone. Welcome to this session where we'll be discussing important questions for ISRO from metrology that comes under manufacturing engineering. Okay, so this is all about me. My name is Rahul Kanyal. I have had a few years of experience working in a PSU called BHEL, and I have a master's degree from the prestigious IISc Bangalore. So here we go. Number of days left for ISRO, you can check it out here, 16. I hope you're really doing good, and if you're facing any fears, doubts, let me tell you that fears are very natural. Even when I come here to give this session, I also face fear. Anyone faces fear. Okay, so it all depends on you, how you handle your fear to get going, to be successful. This is what I want to tell you. Okay, so right now we are going to talk about few important concepts. Alright, so firstly let's start with interchangeability and selective assembly. Okay, good evening everyone, good evening Afzal, Ranjit, Smruti, and let's have a very good session out here. Okay, fine, let's understand what is interchangeability first. Let's say you manufacture two components, okay, and the first component you manufactured 1000 units, second component you also manufactured 1000 units, and you can assemble both these components. Okay, you can assemble component 1 and component 2. So interchangeability says that level of process improvement in which if you pick the first component, okay, one component out of 1000, and if you pick the second component out of second component, they should assemble. This is what it says. For example, let me give you a live demo. I have two pens of the same company, okay, and if I remove this cap of the green pen, or did I say company? Oh, sorry. I have two pens over here. One is green and the other one is blue. They both belong to the same company and the manufacturing process would have been the same. Yes? Yes? Fine. So, what I do, if I assemble this blue with green, it assembles. Alright. Yes? Similarly, if I pick up this green and assemble with blue, it assembles. This is what interchangeability says. Okay, I hope I'm making it very clear to you. Good evening everyone, and I hope you're really doing great out there. So now selective assembly says that you're going to assemble two components that can be assembled only if they are good. Good means that, okay, it says that only assemble quality components. What is the meaning of quality components? It means that are manufactured within a tolerance. Okay, so in selective assembly you need to check each and every component and say that, okay, first component is good, second component is good, then we can go ahead and assemble them. Alright, this is what is the difference between the two. Okay, fine. Now, what do you think might be the answer of this? Interchangeability can be achieved by A, B, C, D. It is just a common sense question. So what do you think? Okay, Deepak says A, good, and more questions. Sachin also says A, fine, I'll take that. And okay, Manoj also says A, Ninad also says A. So okay, fine. So we have 4 A's. So the correct answer is A, is good, fine. So what is the meaning of standardization? Can you please type in there? What do you think about standardization? Yes, it's a previous year question. Yes, exactly. So what do you understand by standardization? No, firstly understand it. Okay, you have gotten it. I want you to understand it. Okay. Firstly, we understand the theory, then we do the questions, not the other way around. Okay, fine. So standard means that adhering to a standard, adhering to a benchmark. Okay. That is what standardization means. For example, if I manufacture this in Tamil Nadu or in Delhi, okay, and according to the drawing, it should be made, it should be made under a tolerance. This is what it means. Okay, and we actually follow. Okay. For example, if I ask you to make M30 threads, they will be made exactly in the same way in India as well as in US. This is what standardization means. All right? Okay, fine. So most of us got it right. Let's move ahead. Fine. A hole is given to you like this and shaft is given to you like this. When they assemble, they will form a fit. Let's also have a discussion about fit. Okay, these are very common questions. They appear everywhere. So the first thing, I'm going to draw it. I'm going to draw a hole first. Fine. Now I'm going to draw a shaft. All right. Now I'm just going to draw this zero line over here. This is the zero line. Okay. And this is the tolerance zone. Fine. So what is given here? This dimension is given to be 60. Yes, a hole is of dimension 60.15. What this means is that this zero line is passing through the lowest limit of the hole. This is what it means. Okay. And this means that 0.15 means that the distance from this line to the maximum hole is going to be 0.15. Agreed? Yes? Okay. Okay, fine. Now, what is this dimension? We look into this. So this is 0.001 from the zero line. So this dimension is 0.001 and this small dimension is 0.011. Clearance fit happens when? Can you tell me when does clearance fit happens? Okay, lots of answers. Okay, C. Sharmila says A. Okay, fine. Hiten says A. Okay, let's have a discussion about it. Okay, when does clearance fit happens? Please come up. When does clearance fit happen? Sorry, when there is always a gap in all the conditions of this tolerance. There is going to be gap always. Yes. Okay, fine. Then interference fit happens when there is never a gap. Yes, that's what it is. So what do you think is the answer for this? For example, let's check for clearance fit. Is it applicable for clearance fit? For example, when the hole is maximum, sorry, the shaft is maximum and the hole is minimum, it will have a interference fit, right? Yes, yes. I said that when shaft is maximum, hole is minimum, we will have an interference fit. Interference fit means that you need to put force to make the assembly happen, right? For example, in case of carpentry, you would have done it in first year. Two assembly blocks, you would have hit them, right? Yes? Okay, fine. And what do you call a transition is sometimes clearance, sometimes interference, right? So as we can see, when the shaft is maximum, hole is minimum, it's causing a interference fit, right? Sorry for that fumble. And when shaft is minimum and hole, let's say, is also minimum, then we are getting a clearance fit. So the answer here is transition fit, because it is sometimes behaving as clearance and sometimes it is behaving as interference fit. Okay, okay, fine. So good, all of you, I congratulate you, you came up with option C. Let's move. All right, now let's also have a discussion about a hole based system and a shaft based system. All right, so let me draw it first like this, like this. Okay, if zero line is a line with respect to which all the deviations are measured, all right? So if zero line passes through the minimum hole, then we say that it's a hole based system. All right, yes. Now let me draw it here. For the same system, if zero line passes through the maximum shaft, then we say it's shaft based system. All right, and this is called basic size. Yes, fine. Now from the zero line to the maximum, if I write this dimension, this is called upper deviation of shaft. All right, this is called lower deviation of shaft. All right, yes, I just want to go back and okay, fine. Here also it was a hole based system. All right, fine. And in this case, this will be upper dimension of hole. Yes. Now can you please tell me what should be lower dimension of hole in this? Just come on. See, you can expect 6-7 questions from this. Zero. Mangeshwaram M says 0. Okay, fine. I asked you a question. What should be the lower dimension for hole in this system? Lower dimension. Sorry, lower deviation, not dimension. Not the basic size. No, we are not talking about basic size. We are talking about deviation. See, this is upper deviation. That is always taken with respect to 0 line, right? This one. This is lower deviation of shaft from here to here. Okay. Similarly, from here to here, this is upper deviation of hole. So I asked, what is lower deviation of hole in the system? Please come up. It's 0. Yes, obviously it's 0. Good. Congratulations, Hiten, Ruchita, Sharmila, Ajit, and Shiva. Good, Manoj. Okay, fine. Again, similarly for this, can you please tell me what should be the upper deviation for shaft in this case? Upper deviation shaft for second case. What should it be? Good evening, Hari. I welcome you here. Please come up. With this, for this system, I asked you what should be the upper deviation of shaft. Lower deviation is, okay, fine. Let me again tell you, this will be lower deviation for hole from here to here. This is upper deviation of hole. All right. Similarly, this is what? Can you please tell me this is what? Can you please tell me this is what? Come on. Yeah, Hiten says 0. Okay, fine. Okay, Shiva, LDS, lower dimension, 0. Okay. See, okay, fine. So this is going to be the lower dimension, lower deviation, sorry for that. And the upper deviation for shaft is going to be 0. Because the 0 line is passing through the maximum shaft. Yes? Yes? Okay? Fine. Now, see, one more question can be asked from this. The question says, let's say, for example, what can be asked? Let's say we have a hole-based system. Okay, then upper deviation of the system equals to A. Basic size B. Upper deviation of the system, not of the system. We are talking about hole. Basic size, tolerance, C is none of the above. Let's say you have just 3 options. Can you please tell me what should be the answer? Okay, the question I'm going to repeat here is that for a hole-based system, so first system we are talking about, upper deviation of the hole is equals to basic size, tolerance, C, none of the above, D, just forget, I've given you just 3 of the options, that's all. You say B, Sharmila says B, okay, fine, come up again, more. Tolerance, fine. C, none of the above, okay. Shiva says B, okay. Okay, so as we can see here, upper deviation is nothing but this distance, which is the tolerance. Right? Good. So I congratulate Mangeshwaram, Gurpreet, Ruchita, BK, Ajit and Shiva. Fine, tolerance, you are getting it now. So these simple questions can be asked from this topic. Usually they ask. Good, Harit, Gurpreet, fine. Now, and you can also calculate maximum clearance, minimum clearance, yes, in these systems. What is clearance? What is the meaning of clearance? Can you please type in there? When I say clearance, what do you understand by clearance? Can you please type in there? Please type in. What is the meaning of clearance? Gap. Yes, good. Gurpreet says gap. Yes, gap. So you can see maximum gap and minimum gap in this as well, right? Yes. So can you please tell me what should be the maximum gap in this? Maximum gap can be upper deviation and lower deviation. Difference should be the maximum gap. Minimum limit of hole minus maximum limit of shaft. See, maximum gap can be when hole is the biggest, yes, and the shaft is the minimum, the least, right? So maximum gap is this. Just calculate this. Yes, and now it depends on you how you calculate this. All the dimensions are written over there. What should be the minimum gap? Can you please tell me? Can you please tell me? Okay, good, good. At least you are interacting. Nice. Minimum gap is this one, right? Yes? Okay, fine. Fine. So minimum gap is lower deviation of hole, right? Maximum, sorry, I'm going to repeat it. Minimum clearance is lower dimension of the hole. Yes, agreed? Fine. And you can calculate this by adding up lower dimension of shaft with upper dimension of hole. This is how it goes, right? It's very easy, straightforward. Fine, fine. So let's move up, okay? Fine. Okay. Okay, fine. Good. Now, please answer this. A basic hole is one whose, this is from previous ISRO question, okay? This is our previous ISRO question, so please answer this. No, actually minimum gap is called allowance, Kumar, okay? Minimum gap is called allowance. It's not basic clearance. Okay, where is it? Where is it gone? It's lost somewhere. Okay. A basic hole is one whose lower deviation is 0, upper deviation is 0. None of the above. So these kind of questions are asked. Fine, we had a discussion about this. A basic hole is one whose upper deviation is 0. Basic hole is this one, right? Basic hole is this one, right? Or is it asking about basic shaft? Too many pages over here, cluttered. Yes, basic hole is one whose lower dimension is 0. Yes, because we are seeing upper dimension of hole. This is the upper dimension hole, right? Lower dimension is 0, right? I hope you are getting this, right? So they might trick you with these questions. So what is the answer? Is it A? Lower deviation is 0. Let me go back. Yes, A is the answer. Fine. Fine. Okay. Lower deviation is 0. Fine. Good. You are catching it up. Yes, it's really, really good. Good. Okay, fine. Okay. Basic shaft and basic holes are those whose upper deviations and lower deviation respectively are. Quickly, please give. Please give. These are just basics, Divya. And unless you understand basics, you cannot go up. So, okay, firstly, just try to understand. This is what my suggestion is. And these I have taken from previous year's questions. That's all. Okay. So, what do you think it is? Lower deviation and upper deviation? Zero, zero, C, Hitesh says C, upper can be 0. Yeah, upper can be 0 for shaft. We saw it, right? Shaft based system. More. Fine. Okay, Divya. We have had a discussion about it right now. Yes. So, C is the option over here. Good. Let's move ahead. Okay, now can you please tell me what's the difference between unilateral tolerance and bilateral tolerance? Can you please tell me? Okay, good. All of you got it. Almost all of you got it correct. It is really encouraging. That you guys are coming here and trying your best. You know, this is what matters. Okay, fine. So whatever tolerancing we talked about over here was whatever diagram we had made over here. I'm sorry for all these cluttering up. Here, these. Here. Are these bilateral or unilateral tolerancing? Now. Yes, Divya is right. Unilateral means tolerance only on one side. So we are just talking about, you know, this basic, this 0 line. With respect to 0 line, we are talking about tolerancing. So here, upper dimension is also in this side, lower side. Lower dimension is also on the lower side of 0 line if we talk about shaft. Yes, so it's a unilateral. Yes, you got it right. Unilateral tolerancing. Sorry for that. Okay. Now, what if I make 0 line like this? Okay, let me use a new one. This is the tolerance zone, this is the 0 line. Then it is called bilateral in this case. Yes? Bilateral. So you get it. Fine. So I'm going back to the question. Okay. So this is an example of bilateral tolerance because this basic size. What is the basic size here? Can you please tell me? Can you please tell me? Yeah, 25.3 is the basic size. So you got it. Very good. So, okay, fine. So are you pumped up with this ISRO test? Are you hopeful? Are you having, belief that I can do it? Are you working for it? Yes or a no? Fine. Yes, most of you are getting it correctly. 25.3. This one is the basic size. Yes. So just tell me, are you pumped up for this examination? And let me tell you that the most important thing to crack any examination, yes, Mangeshwaran, you're working hard, it's really great. But let me tell you that the most important thing to clear any examination is something called belief. So do you believe that you can do it? You know, you can work hard, you can work for 24 hours, you can work for 20 hours, but still it might happen that you're not successful, right? So what is missing in there? This is missing in there, belief. Okay, you need to believe in yourself that you can do it. Just keep on telling yourself, I can do it, I can do it, I can do it, I can do it. Okay. Have you seen have you seen this movie Kung Fu Panda? Wonderful movie, right? There's a very famous quote in that. It says that a real warrior never quits, right? A real warrior never quits. So keep on moving, even if you're discouraged, even if you're fearing it, even if you're fearing the failure, just keep on moving, keep on crawling towards your aim. You're going to get it. Okay, fine. Okay, now let's come to this question. Can you please solve it for me? It's very straightforward, right? You have to find P, Q is given, W is given. So let's do this. Come on, come on, come on. Can you please do this? So you say 7 plus minus 0.2, fine. Ashish, good. 7.2. Okay, we are not talking about just one value, okay, because this is in terms of the tolerance. We cannot get just single value. Yes, Rahul also says that 7 plus minus 0.2. Okay, fine. 6.82, 7.2. Fine. Shiva says 6.82, 7.2. Fine, fine. Okay. Okay. Rukna nahi hai. Yes, you should never stop. You know, keep on working for it. Also take relaxation. Okay. Sharmila, it cannot be just 6.8. Yes, I'll take this 7 plus minus 0.2. Vijay Bhaskar also says 7.2. Vijay, it cannot be just one number, okay? It has to be in this. P should also have, see, something like this, x plus minus y. Right, because we are talking in terms of tolerancing. Tolerance. Preetham, okay. Most of you are getting it. I'm really happy. Fine. So what's the approach? Approach is that, what is the approach? Approach is that P equals to Q plus W, right? So P max must be Q max plus W max. Yes, similarly, P min equals to Q min plus W min, right? So what you are getting? P max, Q max you can calculate, right? Everything can be calculated. Q minimum, Q max. Quickly we are going to do this. Q max equal to 5.1. Yes, and W max equals to 2.1. Q minimum equals to 4.9, right? Q max equals to, sorry, W max is 2.1, Q minimum is 4.9, W minimum should be here. W minimum should be 1.9, yes. So when you plug in these values over here, what do you get? What do you get? 7.2, is it? And here what do you get? 6.8. Am I right? Am I right? Yes. So P max, P min we have gotten. So how can we write P? We can write P as 7 plus minus 0.2 as you told. So you are right. Very good. Fine. So this is the approach. Okay. This is the approach. Now, what is happening here is that if this question comes up, don't do like this, because there's a quicker method for this. What you need to do is, because P equals to Q plus W, I'm going to write it over here. All right. P equals to Q plus W. Okay. So what you need to do is just add these two values, the basic values. Basic value for Q is 5, basic value for W is 2. So 5 plus 2 plus minus, you just add the tolerances. Okay, that's going to be 0.1 plus 0.1. So the answer here is 7 plus minus 0.2. Obviously units. Yes. Fine. Okay. Okay. So here we are. Is that good? Now, in the same way, can you please find, okay, let me give you 7 P, okay, P equals to 7 plus minus 0.2, and let's say we take Q equals to 5 plus minus 0.1. You have to find W. Can you do it? Similarly, okay, what I said that P equals to 7 plus minus 0.2 and Q equals to 5 plus minus 0.1. Can you find W? Yes. Can you do it? Quickly, quickly. Can you please do it? Similarly, we have to do this. Okay. 2 plus minus 0.1, he says. Okay, fine. Fine. Shyam says 2 plus minus 0.1, good. And 2 plus minus 0.1 again. Okay, fine. Good, good, good. 2 plus minus 0.1, yeah. So the method is the same here. Okay, similar method. Fine. Okay. Okay. Bhavantik says 2 plus minus 0.3. So which one is right? 2 plus minus 0.1 you are saying. Okay. So I suggest you go this way, not this way initially. Then see what's the answer. Okay. W should be P minus Q, right? So I suggest just go through. Yes, whosoever is getting 2 plus minus 0.3, I think that is correct. Okay, that's why we talked about this method over here. This method, not this method. Okay, this is just a jugaad kind of method. Fine. Okay, this is logical. This isn't logical. So I suggest please try this one. Okay, you calculate Q max, W max and all, P minus Q. So W max will be P max minus Q min. W minimum will be P minimum minus Q max, right? W is P minus Q. Yes. So W max equals to P max minus Q min. W min equals to P min minus Q max. Yes, yes, yes. So you will be getting an answer of W equals to 2 plus minus 0.3. Please try this. Yeah, it's my pleasure, dear Sham. Okay. Akshay, no, you won't be getting 2 plus minus 0.1. You will be getting this. So I suggest go through this. Whatever we have done, just check it. Okay, you will be getting this, I think. Yeah? Am I correct? Yes? Hello? Say yes if I am correct. Yes, that's how it is done. Okay, fine. So here the conclusion is that even if we are subtracting, okay, what we did, we just subtracted this. This is how it will come, okay, through the logical method, not through the Jugaad method. Jugaad method says that just do this, subtract the basic values and again add the tolerances. Tolerances are added. So I'm going to write here, not this, 0.2 plus 0.1. Okay, so please remember this. Yes, tolerance are always added. Hiten, you're right, absolutely right. Good, I like it. Right? They are always added. They are not subtracted. Okay, fine. This you need to remember. And I am taking it because this might be asked. All right. Okay, fine. Now, can you please try this using the logical method, not the Jugaad method? Can you please try this? Wire has mass 0.3 plus minus 0.003 gram, radius itna, and length. The maximum percentage error in the requirement or measurement of density is. Can you please try this? Come on, come on, come on. Similarly, you don't have to use Jugaad method, you have to use the logical method because it always works. All right. Yes, yes. Can you please try this? Are you trying? Say yes if you are trying. See, yes, all of these questions appeared in previous years' papers from ISRO, okay? Density. Okay, 1. Yes. I don't think it's that easy. Okay. I really don't think that's so easy. Okay. It'll take some time. Fine. So, what is density? Mass per unit volume is density, yes? Now, what do you have to calculate? You have to calculate percentage error, the maximum percentage error. You have to calculate this rho max minus rho min upon rho average, or you might want to write rho basic in 200. This is what you need to find. Agreed? Sham says that it's coming out to be 0.08. That's just this fraction. You need to also multiply it by 100. Sham, how much is it coming? No options? Okay, just hold on, okay? We are just trying to find it out. So rho max equals to, what should it be? M max upon V minimum, right? Rho minimum should be equal to M minimum, mass minimum, upon volume maximum. Yes, you can calculate M minimum, M maximum from here. Similarly, you can calculate the minimum value of radius, maximum value of radius and length as well from there, right? The tolerances are given to you. Fine. Yes? Okay. Now rho basic is M basic upon V basic, right? So I'm going to write it just this thing for you. M basic is 0.3 upon V basic. What is V? Volume. What do you think volume is in this case? Can you please type in there? No, P max is M max upon V minimum, right? Let's write the formula of volume. What should it be? The volume of wire. It has radius and length. What should be the volume? It should be pi r square L, right? It is cylindrical. A wire is cylindrical, right? Yes. Yes. Okay. Then V minimum should be pi r minimum square into L minimum. V maximum should be pi r maximum square into L maximum, pi r square L. Yes. And V basic should be pi r basic square into L basic. Yes, good Sunil, yes, pi square L, you are correct, absolutely correct. Okay, now you need to calculate all of these and come up with an option. So V basic I am just going to write here. V basic is going to be, what is R basic over here? Can you please tell me R basic, what is R basic? What is the basic size of R? Come on, come on. I know you know this. We have been discussing the basic sizes. R is 0.5. Yes, Yoga, you are right. That is 0.5 whole square into length basic. Basic size of length is 6. All right. So I think 6, yes, you're getting it. Yes, good, fine. So you just need to calculate all these 0.5 and 6. So we said that V basic equals to pi r square into 6. Similarly, you can calculate V minimum. You can calculate R minimum from here. Similarly, R maximum from here, right? And I think you know how to proceed. Yes? Can you do it now? Can you do it now? So I have few values, I am going to write them here. Rho max you will be getting at around 0.06627. Rho minimum you will be getting at around 0.06117. rho basic, you'll be getting at around 0.0606 0.06366, 0.06117, 0.06627. Okay. Who was saying that? Okay, Sham, you were saying that it doesn't have an option, right? No. Actually, yeah, it is very much time consuming. So so what you are being tested here is that if you see such kind of a question, you have to leave it. Better not to attempt it. They also check this anywhere, any exam that you give, be it GATE, be it IES, be it anything else. What they check is your ability to leave questions. That's how it is. Okay. Yeah, exactly. Without calculator, it's very difficult. So once you plug in this, let's see what is coming up. Can you please calculate with these? I know. So this is the question that you need to leave. You need not attempt this question. No tricks. No tricks, Sham, for this. You just need to leave this. So you should know when you should leave it, right? You should know when you should leave a question, and you should know when you should attempt a question. All right? That's the only trick over here. Fine. Sham, there isn't any trick over there, okay? Fine. So can you please calculate the answer? Can you please do it? Can you please attempt? Can you please attempt it now? How much is it coming? Sham, how much is it coming? Sham Mohan. I mean, how much is this percentage error coming up? How much? How much is it? Akshay, how much is it? B. See, all you're not getting any answer, right? How many of you are not getting any options in this? Yeah, it should be 8% exactly. So it's a wrong question. Sometimes this also happens. Okay, you should be aware of this, that don't waste too much time in a question that you cannot find the answer. And because we have followed it, we have followed all the logic in this, right? Everything is correct over here. We know that we have followed a correct logic, and even if you're not getting an answer, the learning here is that leave it. Yeah, it should be 8% around. Okay, should be around 8%. Sometimes it happens. It also happens in GATE that the questions that come up are faulty. They are not accurate. Okay, this might happen anywhere. So that's why I've included this question over here. I hope that it gave you learning. That's the only thing I want to tell you. Okay, fine. Okay. Yes, 8% should be the answer. So you cannot get 3% or 4%. You're not getting this. Yes, okay, fine. Okay, you're saying this centimeter, this is a typo. This should be mm. This is just a typo, okay? Sorry for that. That's just a typo, okay? Fine. Okay, if you can take up a shortcut, then it's good. But I don't suggest shortcuts because everything should be well understood. Okay, fine. Now we conclude this session, and I hope you had a very good learning experience over here. I hope that you are going to believe in yourself, that you're going to crack it, right? If you're feeling short of confidence, just say to yourself that you're going to crack it, no matter what. Believe me, I have given GATE, I have given, I have also worked in BHEL, I've worked in IISc. I've always believed that I could do it. Okay, you also need to believe that it can be done, it can be really done. Then once you believe in this, you get a drive from inside, you get power from inside to do it. You get a majestic force from inside. Okay, that is going to help you there. Here it is just a mock-up thing. Here it is just, it's not the real test, right? It's not the real cricket match. There you are going to play the cricket match. And this belief will take you up. This belief will take you, it'll keep you moving and moving. So can you do it? Mangeshwaran, I'm really sorry that I cannot tell you this ISRO admit card release. Maybe our team can come up and help you with this. Or maybe, I don't know if they have an idea about it. They should be having. Okay, fine. Thank you, Akshay. Thank you very much. God bless you. Be blessed by the divine. Do better, do good, do really good. And I believe that, you will come up with flying colors in ISRO and all the exams that come up. And don't forget to take rest, okay? You have to rest. Tomorrow, again, I am going to come up with similar sessions, similar basics. And try to help you with further questions and concepts. And I'm going to repeat that you need to understand first, then do the questions, not the otherwise. Okay, I really had an amazing experience with you. Thank you very much. God bless you.